Two more things to teach you. So your test, I need to confirm, your test is going to be Wednesday of week 3, not Wednesday of week 2 like it says on the timeline. You'll get 2 practice tests, one that is made up of a bunch of questions from the review sets that are similar to what's in the actual test, and the second practice test will be similar write-up, similar formats to the real thing. So the second to last thing I need to teach you about is the idea of multiple optimal solutions. So let me remind you of this. This was the homework reminder that I sent on Friday before the holidays started. So I taught and I gave you time to work on the exercises to the end of exercise 2C.2. Number 1, if you didn't read this, that's your fault. Number 2, if you read it but you ignored it, still your fault. So yeah, it's your fault if you weren't up to date. You had 2 weeks. There was 4 people that attended the holiday tutorials. I know they're up to date. Whether you are or you're not, you're the one who needs the grade from me. Does that make sense? Let's start. So this is going on from exercise 2C.2. This is for 2C.3. What you have been practicing on the timeline is the simplex algorithm. And what does that mean? You can find the optimal solution by drawing a simplex. You color in that little shape and you find the corners. And I told you in that lesson, all we are doing for the rest of this topic is the same thing with slight variations. Those people that are up to date will tell you that that's a true statement. Okay? However, today, what's the variation? Sometimes you're going to notice that 2 of your vertices in the little table that you write up give the same optimal value. So it appears that you have equally optimal solutions. Those 2 aren't going to be the only solutions. So I'd like you to get down, please, these 5 steps for how to deal with multiple optimal solutions, and then I'm going to demonstrate it. So step 1 is you do the simplex algorithm as normal. No difference to what you've done before. Step 2, you're going to do that table, but it's going to be weird because you're going to have 2 results that you put a star next to. So I'll get you to get those 2 steps down, which is what I've explained to. Did you see that email?
I didn't think it came off.
Okay. Is this a Mac?
Yep.
I'm going to add that to you. I think it was because I sent the whole booklet and it was like 30 megs, so it might not have allowed you to receive it. So I'll airdrop it to you now. Is your receiving on?
Yeah, it is, I think.
Okay, I've made you your own timeline. Archibald?
Mm-hmm.
That's your timeline. And this is the booklet for finance because I didn't ask you to borrow it from the library. I'm sending them. And I'll resend the email without the attachments so that you can see what I wanted to say. Put those in a folder, smash through the finance topic, and your advantage will be you can send as many drafts as you want until the only option is an A+. Does that make sense? Okay, step 3. What's different? Your table is going to have 2 things that you put a star next to. How do we deal with that? You need to identify the 2 vertices in your graph, and you need to look at the line between those vertices. And then step 4, look at all the whole number points along that line. And what is the significance of those whole number points? They are also optimal solutions. So do steps 1 to 5, get those down, please. And then I'll move it in such a way. The example that we're going to do is a callback to that first one we did in 2C.1 where Hano was trying to get jacked. The only difference is the costs for Power Boost and Super Health are now slightly different. So get steps 1 to 5 of the dealing with multiple optimal solutions. So your specific timeline, you don't need to do these two. Skip those. You'll also get a double advantage because in the last 2 years, what people have done, because the DI is actually getting you to practice these, they didn't even bother doing the timeline stuff. You could do that if you wanted, but remember you're going to be tested on that with a test anyway. So the more practice, the better. I'm going to scroll down. What I would like you to do, please, you've got that example, which is the same as before. It would be good practice for you to pretend that that was your question. You got 10 minutes from now, because that's how long you would have in the actual test, to get from that worded problem to your graph with the coloured in shape, which is what you practiced up until 2C.2. So I'll get back to you at 20 past. Get that info into a labelled simplex. So that's the graph with the labels, yep.
Can you scroll up a bit so I can get the last two down?
Because I've already got it drawn, you answer it, you try to draw the simplex, and then I'll scroll down and we'll compare if you get the same graph as me. Because up until this point, there is no difference to what you've been doing previously in the exercises. There's 2 questions in your test where you have to draw the simplex from scratch like this. The other ones, they're partly drawn for you. What is the important stuff? 30, 30, 100, 10, 30, 200. Must get 170, at least 1400, no more than 330. Nine minutes. You do have a graphics calculator?
I don't know. I think my sister might.
Okay.
But
For now, because this topic is fully handled by your graphics calculator.
she's the
There's-
online one.
Just use Sage Calc for now.
Oh, I think you sent me a link for that. So
Yeah. The school will always provide you one, but it's a little bit different pressing it in front of you than
I was
using it.
actually going to work at home.
Yeah.
It's easier to
Yeah. Draw your simplex. You got 8 minutes now. If at this point in your timeline you're not sure where to start, you need to be worried. I'm not worried, I've been here. I've been available to help you. Or do I get the 10 minutes from? Your tests are written on the basis of a mark a minute, with a leeway of about 20 to 30 minutes because you're students. You'd have 5 minutes now. What's going on there? Someone's getting told off in the back. Drawing your simplexes is slightly easier in the test because I give you the right space on the grid, whereas in your book you don't know how much grid you need. So if you're going crazy trying to work out a scale in the test, you did something wrong. Three minutes and I'll show you the working and then actually what's new today. Even though it's a double, I'm only doing this one thing because you guys need to get back into school mode. Because those holidays are kind of annoying. Three minutes. Couple of minutes. Hopefully you're drawing your lines and colouring your shape now.
What did you say you wanted us to do up to?
Just draw the lines and colour in the shape. That's it. If you've done, have you done that?
Yeah.
That's a good speed. Good. You'll actually have a little longer in the tests you do. Because every year after we come back from the holidays, there'll be people that just have no idea where to start. That would be a worrying situation, okay? Is that him? Is he in that situation? Okay, what I'm going to do is show you what working out should have occurred for that. The working out should have looked like that, because we did it before in 3C.1. Your simplex should look like this, okay? So the corners should be at 3, 8, 8, 3, 4, 5. We have done nothing different to what you have been asked to do on the timeline. Still nothing different. I'm going to do my little table, vertex, objective function. The new objective function is 1x plus 2y. What are my vertices? 4, 5, 3, 8, and 8, 3. Still no difference. Still nothing different up to this point. So I'm going to go 1 times by 4 plus 2 times by 5. That's going to be 14. 1 times by 3 plus 2 times by 8. 1 lot of 3 is 3, plus, so that's going to be 19. And 1 times by 8 plus 2 times by 3. That's also going to be 14. That is what's new. Okay? We have done nothing different, but this is what's new, because we were trying to minimize Hano's costs. Buying 3 and 8 is going to cost $19. That's not the minimum. But 4 and 5 is $14. But what's different today is you've got another minimum, 8 and 3. So what's new in this, step 3, identify the two vertices in your graph and look at the constraint line between them. So I'm going to put a circle around 8, 3 and 4, 5. And now I am looking very closely at the line between them. And the step says, look at all the whole number points along that line. So if I zoom in, is this a whole number point? No, because it's halfway between 4 and 5. Is this a whole number point? Yes. So that is another optimal solution, which sits at 6 and 4. Is this a whole number point? That's in between. So that's all that's new today. When you do the table, you're going to see that there's more than one. They aren't the only optimal solutions. Any whole number point that's along the line between those two is also optimal. So your answer to this would be, therefore, Hano would minimize cost by purchasing. What are my situations? I need to do this one. I need to do this one. And I also need to show that point in the middle. So by purchasing 4 power boost and 5 super health. What was the next one? 8 power boost and 3 super health. And what's the new little dodgy one that we learned about today? 6 and 4. Because it's on the line between them. 6 power boost and 4 super health for $14 total. That's all that's new. So you can see that when you're dealing with multiple optimal solutions, it's the same as everything that you've done before. What is the only difference? If I get 2 optimals, what do I need to do now? I need to look at those 2 points. I need to look at the line between them. and I need to find where there's a grid line crossing because that's also optimal. If you don't believe me that that's optimal, let's put 6 and 4 in here. What's 1 times by 6 plus 2 times by 4? That's also 14. So it should confirm, okay? That's it. That's your lesson for today. You're working on exercise 2C.3, questions 2 and 4. I'll move that up here so you can see it, and then I'll leave the example there.